You can determine and graph equations in point-slope form even when you are given limited information. For example, if you are given the slope and any point are values for x1 and y1, then by substituting the point into the equation for x1 and y1 and the slope for m, you have the equation of the line with no additional work required. Or if you are given any 2 points, it's always possible to determine the slope using our slope formula, so that would give you the value of m. And then by substituting in one of those given points in for x1 and y1, we can write the equation of a line from 2 points. So let's clarify the steps required by doing some examples for both cases. So here's an example. Our first example where we're given, write the equation of a line in point-slope form that has a slope of 8 and passes through the point -7, 4. So we're given a slope of 8, so we already know that m equals 8. And we also know that a point that the line passes through is -7, 4, so that's going to represent x1 and y1 respectively. So by substituting these numbers into our equation, remember y minus y1 equals m times x minus x1, we automatically have y minus 4 equals 8 times the quantity of x minus -7, which if we simplify, if we rewrite minus -7, we get our point-slope form of our equation as y minus 4 equals 8 times the quantity of x plus 7. Here's a different example, same idea, where we're writing the equation of a line in point-slope form that has a slope of -4/3 and passes through the point of -5, -2. So the first two things we need to know to write an equation in point-slope form are what is the slope and what numbers represent the point x1, y1. Well, we're told the slope of -4/3, so our slope equals -4/3. And we're told the point -5, -2, so that is going to be our x1, y1 values. We know that's going to be -5, -2. It's right there in the given information. Now that we have those values, we need to substitute those numbers into the point-slope equation. Remember, that's y minus y1 equals m times x minus x1. So it will be y minus -2 equals -4/3 x minus -5, which we need to then simplify our double negatives. So our equation becomes y plus 2 equals -4/3 x plus 5. Now let's look at the other type of example where instead of given the slope and a point, you're given 2 points. This example reads, write the equation of a line in point-slope form that passes through the points 3, -7, and 5, 0. Remember, in order to write your equation in point-slope form, you need to know the slope and a point on the line. Well, here we know 2 points on the line, but we don't know the slope this time, so we need to calculate it. If we use our slope formula, y2 minus y1 over x2 minus x1, we'll say that 3, -7 is x1 and y1, and 5, 0 is x2 and y2. So that will give us 0 minus -7 and 5 minus 3 in the numerator and denominator, which gives us a slope we calculated of 7/2. So now, since we know that the line passes through the point 3, -7, the first point, our x1, y1, that can represent x1 and y1 respectively. So by substituting these numbers into our equation for point-slope form, we have y minus -7 equals 7/2 times the quantity of x minus 3, which if we simplify that double negative, it simplifies to the equation y plus 7 equals 7/2 times the quantity of x minus 3. Now, you might be asking if the equation on the previous slide is the only answer, because we use the ordered pair 3, -7, but actually you can also write the equation in point-slope form using the other point of 5, 0. If we use that as x1, y1, and now remember the slope is still going to be 7/2, But now our y1 is 0, our x1 is 5, and if we simplify y minus 0, we get the equation y equals 7 over 2 times the quantity of x minus 5. So the reason that we have two possible answers for point-slope form of this equation of this line is because they would both simplify into the same equation in standard form. So below we can see if we start out with our two different point-slope answers, and by doing a little distributing, getting rid of our fraction, and solving, and getting the x and y both on the same side, getting that coefficient of x positive, we end up in both cases with 7x minus 2y equals 35. So really, you have two possible choices or two possible answers for writing the equation in point-slope form. It just depends on which equation has x1 and y1 with which point as those values. Let's do another example just to make sure we understand this idea. So we're going to write the equation of a line in point-slope form that passes through the points. We have negative 8, 5, and negative 6, 1. So first we need to know the slope, and then we need to know what numbers represent x1 and y1. So the slope we can find using the slope formula. We have x1, y1, and x2, y2. So that would be y2 minus y1 is 1 minus 5. x2 minus x1 is negative 6 minus negative 8, which is negative 4 over 2, which is negative 2. So m equals negative 2 for that line. So what numbers represent x1 and y1? You have two choices. It could be negative 8, 5 or negative 6, 1. So when we substitute in the numbers into the point-slope equation, we're going to have two options. We could have y minus 5 equals negative 2 times x minus negative 8, which is from using x1, y1 as the ordered pair of negative 8, 5. Or you could have the equation y minus 1 equals negative 2 times the quantity of x minus negative 6, which is if x1 and y1 is from the ordered pair of negative 6, 1. You have the choice, it's or. Notice the slope is the same though in both. The slope is always the same because remember, any 2 points the line passes through should always have that slope, but it just depends on which point you're looking at. And of course, we should simplify, clean up those minus and negatives. So our answer, writing the equation of the line in point-slope form through those 2 points, could be either y minus 5 equals negative 2 times the quantity of x plus 8, or y minus 1 equals negative 2 times the quantity of x plus 6.